the function is. Now this, I have to admit, that doesn't look too clear back where you're sitting in the back, but that notation is, yeah, it's not that. Let's get a pen up here. That notation is a prime mark, okay? That's the notation we use. That's what this is right here. If you can't read it, that's a prime mark. That prime mark on the function's name tells me that what we're actually doing is taking the limit as the input values get closer, or the difference between the input values get close to 0, and we look at the slope of the secant between 2 points. That's what this little prime, that little prime mark has a whole bunch of stuff written into it. That's why it's called just a little notation prime mark. But you got to remember, it's not just f prime. It means this whole thing. Provided the limit exists. A function is differentiable if its derivative exists. So we use the word, is it different? What's the function is differentiable? The differentiability of a function. So we use that word a lot. So we're just meaning, does the derivative exist? And the process of finding a derivative is called differentiation. That's all. Okay. Now all we're going to do is just kind of work on some problems. See how many of these we can get done. Find the derivative. Now I can tell you that if you've had calculus before and you know the shortcuts and you want to use those on the test, you may use them, but they won't count for any points toward the problems. Okay? You have to use this with the limit process. This is what this whole section is about. Use the shortcuts to verify that you did it correctly, but you must still show me the limit process, and that limit process means this. Okay, so the derivative is the f prime. I would like you to do this also. It's the slope of the tangent. Just give yourself that little reminder. It's the slope of the tangent. It's the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by what? Delta x. Yeah. Okay. That's what you're going to write, and that's just what we have to start with. Now, for us, our specific one is going to be this. It is the limit, delta x approaches 0. Now, let's see. What does f of x look like? That's the easy one, isn't it? 4 divided by the square root of x. Okay, so we can put that in. It's 4 divided by the square root of x. But what does f of x plus delta x look like? Everywhere you see the input, you're going to place what? So it's 4 divided by the square root of x plus delta x. All of it divided by delta x. Okay. Now, we got a lot of algebra to clean up here. A lot of algebra. First thing I suggest we do is that we rewrite this numerator. I'm just going to work on the numerator for a while. Now, I've got to bring everything else along at each step I do, but we're going to focus on the numerator. That numerator is 2 fractions. 2 different denominators. So if I have 2 fractions of 2 different denominators, I got to get a common denominator. That common denominator is going to be what? Well, it's going to be the square root of x plus delta x times the square root of x. Okay? So this is going to be 4 the square root of x divided by square root of x plus delta x times the square root of x. And I'm going to keep those separate. We could combine them, but I'm going to keep them separate. Minus, and what I did was I just multiplied, I'm going to put this in highlight here. I just multiplied by a factor of 1 there. And I chose, of course, the denominator over here. The square root of x divided by the square root of x would be 1, and so by doing so, though, I'm going to have a common denominator. And over here, I'm going to have the same common denominator. But now I have to multiply the numerator of this one with the factor down here. So this is going to be 4 square root of x plus delta x. And so my common denominator, what I multiplied with was a fraction that looks like that. Okay, that's equal to 1, so I didn't change the value at all. Okay. Now, what can we do with that? Well, I've got the same denominator, right? My same denominator means I can add, subtract. So let's see, the limit delta x approaches 0. And I've got 4 square root of x minus 4 square root x plus delta x. All of that divided by square root of x plus delta x times the square root of x. Denominator delta x. This is a lot of algebra here. Okay? Well, let's see. Do you see a fraction divided by a fraction? Numerator is a fraction. We can see that. I just added the denominator to be a fraction. Well, let's see. If I do that and think of that as a fraction divided by a fraction, then if I take this and I invert and multiply with this, I'm going to have 4. In fact, I'm going to factor out a 4 on that. No sense writing it more than once. Might run out of ink up here. And I'm just joking. And then I would have delta x, and I would have the square root of x plus delta x times the square root of x. Can I do direct substitution yet? Not yet. Not yet. Is there any algebraic move that I could make? Man, not there yet. But we've done this before. I'm pretty sure we've done this before. Ever hear of rationalizing? Yeah, well, what do you think? Well, see, some of you tried to do that last week, I think. Was it in this class? If I just square this, haven't I changed the value? I wrote to you about that. You know, if I have 2/3 and I square that, that doesn't have the same value anymore. And some of you, I think, tried that last week. So we can't do that, but it's similar to that. Well, we need to rationalize the numerator. That's the process we're going to use. But what do I multiply with? I don't square it, but I do something close to it. What do I do? Pardon? Someone said something I think was very close, if not absolutely correct. Yeah, what is a conjugate? What would the conjugate be for this? It's identical except we change the sign. Yeah. You know, if you've got a plus b and you have a minus b, then you have a squared minus b squared. What happened to the outside-inside terms? Yeah, same thing happens here. So we have to use the conjugate. Okay, so let's use the conjugate. Now, I didn't give myself much room over here. So let's see if I can squeeze this in here. It's going to be the square root of x plus the square root of x plus delta x. I just kind of scribbled that, but it looks like I wrote it. Okay. Times the square root of x plus the square root of x plus delta x. Go back and listen to this if you want to see what that is. But that's the conjugate. That's identical to this, except it has a plus sign in it. If I multiply this binomial with this one, we can't really call it a binomial, but this term with this term, and they're conjugates, I end up with x minus x plus delta x. Square root of x times the square root of x is the square root of x squared, which is x. Square root of x plus delta x times the square root of negative the square root of x plus delta x is the square root of that quantity squared, which is just x plus delta x. Okay? And my denominator is going to look horrendous, but hang on, it works. This is why you have to write all your work out. You have to do that. Can I use direct substitution yet? After all this work, isn't it time to use direct substitution? But you see, I still have this factor of delta x. I don't care what's back here. If I have a factor, I have 1, 2, 3, 4 factors down here, it's still there. But if I can cancel this delta x with something of a factor up here, I've got it. Am I close? Look at what's inside the brackets up here. I have x minus the quantity. That's the same thing as x minus delta x. What happens to the two x's? Drum roll. They cancel out. What does that mean, make the delta x up here? Is that a 4 minus delta x? Oh, careful. Because you're multiplying, aren't you? And the only thing left inside the brackets is negative delta x. So that delta x cancels with that delta x. What was our trouble? What was our problem? Why couldn't we use direct substitution? Because of that thing. It's gone. It's gone. Okay, so now you got to keep in mind what we've got. I'm going to write this one more time just to make sure that everyone sees it. I have 4 times negative delta x. Whoops, I don't either, do I? What do I have up there? I just have a negative 4, don't I? Because the delta x canceled with factor. Be sure you're only canceling factors. And then I have all of this stuff. I'm tired of writing it. How about you? Okay, I'm tired of writing. But here, now can I use direct substitution? I still have delta x's down here, though. Does that bother me? Why doesn't it bother me now? If I put 0 into these delta x's, is it going to make a 0 denominator? What's x plus 0? X. What's x plus 0? X. Did I make a 0 down here? No. So it's okay to have them down there, just not as factors. Just not as factors. So now, if I can use direct substitution, do I still write this? No, absolutely not. So I end up with negative 4 divided by the square root of, I'm going to put this in just so in case anyone wants to look up and see it. More simply, let's see, I've got the square root of x times the square root of x times the quantity square root of x plus square root of x. Careful when you combine those. Square root of x times square root of x is x, okay. What's this going to be? 2 square root of x, which ends up with negative 2x the square root of x. Do you have to rationalize the denominator? No. Do I need to go back and repeat myself? I think I do. Forgot. What did I say? This is a function. It is a function that allows us to determine what? Slope of any tangent to any point to what curve? Up there. Okay, very good. Now, again, to do this, no, I don't want you. Okay, I'm going to put this function in. What was the function again? Was it 4 divided by the square root of x? Okay, so I'm going to do 4 divided by the square root of x, and I'm going to graph that. Okay. Now, we're going to throw out a few things here. We're just going to see what happens. What if I put a point on here, and I put a point right about there? I don't know what point that's going to be, but it's going to be, what, 1.83? Okay. And I'm going to, let's make it a little easier on ourselves. I'm going to make that to be exactly 1. That should be easy enough to figure out, right? Put 1 in, we get a 4 back. But what do we want to do? We don't want to point with the output of the function. We want a tangent. Okay, so I'm going to put a tangent on there. And what about that tangent am I wanting to investigate? Slope. Okay, so I'm going to go in here. I'm going to find measurement. I'm going to find slope. I'm going to point to that. And my slope is -2. I'm going to alter that text a little bit so that I know exactly what it is. It's the slope of the tangent is -2. Am I correct on my work over here? What is the derivative? What was my input at 1? My point of tangency? Okay, what's my input, my derivative at 1? -2 divided by 1 square root 1, is it -2? Yes. Good. Okay, let's change this. Let's change that point. There we go. Come on, hover. Come on. Got to get that to where it says point. If I can't get it to be point, what I'm going to do is tab. See if I can get over here. There, until I don't want that. Well, graph, no, not that, not the line. Yeah, that's what I want. So I'm going to hit enter twice. Well, come on. I'm trying to hurry, and it's not doing it. There we go. We'll just move it up high. There we go. Had to get it out of the way, so I moved it out of the way. What point do you want now? How about -5? Can I put -5 in that function? I don't think so. Can't do a square root of negative. Okay, so let's put in something else. How about, what is it? 1.78? Good, I like that. 1.78. Slope of the tangent at 1.78 is about 3. I don't think it's exactly 3. I think it's, and we'll see. We'll see if that happens. Okay, how do we know? F of 1.78 equals -2. 1.78 square root of 1 point. How are you going to figure that? I don't want to take the square root of that, do you? I'm going to add a calculator. Somewhere in here is my definition. No, it's not going to be there after all. I'm going to, I've got to put this in here, don't I? So let's see. Help me out if I get forgetting what it is. I want -2. What was the denominator? Oh, come on. I know. This is what happens when I try to hurry up for you guys. I'm blaming you, of course. What is it? 1.78? Yeah. Okay. Times what? Square root 1.78? Uh-oh. that what I got over here? Oops, where's my tab? 0.842? Wow, it does work. Okay, it does work. So, that problem is a horrendous thing. Anyone want to agree with me on it? I'll try not to, because what complicates it is you have to do a common denominator and then rationalize the numerator. That's what makes it work. But you did it. You can do it. Go back. If you can do this problem, you got it. Okay? So practice this one problem. Practice this one. Okay. I've got your TNS files and review of derivative. And here is the statement that I gave you. And again, you guys were close. Some of you remembered some of the key words that we have here. The derivative is a measure of slope, but it's the measure of the slope of a line. And the line is a very special line. The line is one that is tangent to a curve at a point. So derivative is the measure of slope, and it is the slope of a line, the measure of a slope of a line. A very special line, though, a tangent line. Tangent to what? Well, to a curve, to the function graph, at a specific point. Okay. Let's go ahead and just kind of pick up. This was the problem that we worked on, and as you recall, it took us forever. I hope you go back and review that, because a problem like that can take up, I could give you one of these, and for some of you, it might take you all 45 minutes of the test time. To do this, you only have maybe another half an hour to do do 5 more problems. So I will try not to. Angie asked me not to put one of these on the test, but please go back and review that. And remember that when you review this, you're going to only look at that much of the problem. You're not going to look at the way that I have, that we developed the answer. And also remember that when I give you a problem like that, I always tag on a part B. And the part B says, show me what you understand by drawing a picture, a graph of this. And so just keep that in mind. We're going to do more of that today, so if you're not quite sure where I'm going on that, we'll have a chance to see it. Okay, again, some of you have come in with a lot of background work in derivatives, and you know all kinds of shortcuts to work on. I don't want you to forget those. I want you to hang on to them. That's where section 2.2 picks up, is all those shortcuts. But we have to know why those shortcuts work and what happens, and that's what we do with the limit process. Now, on the test, because that'll be the first opportunity for me to assess you on section 3.1. On the test, if you give me an answer and you show that you correctly used one of those rules that you've known, and that's all the work you show me, I will give you 1 point credit, but you won't get all the other points for the problem, okay? And you don't want to miss out on 9 other points or whatever I deem that problem to be. So don't lose that information. You know, it's still good information, but we need to know more. Okay, so it says use the limit definition and to find the equation of the tangent line. So here we go. Our work, when it asks us to do this, our work, the first thing we're going to do is to put down, like I remember, have I shown you this notation, f prime? Okay. F prime of x, and when we have that prime mark up here, the next thing you really should put down, just to remind you of what it is, when you find an answer, when you have an output to this function, you have found the slope of a tangent. How do we use the limit definition? Well, we start by saying the limit as delta x approaches 0. Delta x is our input then in this limit problem. It doesn't look like a true limit or a true input, but that's what it is. And we're going to, you need to write this down so that you will always remember and not have to panic, not give me one of those question marks. I wonder if that's the answer or not. But actually you'll know with confidence. This is the limit definition. We're going to break it down a little bit once again. Again, delta x. What does it mean? Yeah, change in input values. Okay, the change in input values, as we have one point in mind, as we're looking at one point, we're trying to find the derivative at that point, we consider what happens if I have a point a little ways away from the given point. And as the distance between my point and the other point shrinks to zero, goes to zero, the difference moves to zero, I want to know what happens to this. This is nothing more than what? Slope. The difference in the outputs is the numerator divided by the difference in the of the inputs in the denominator. So this is what we need to do, and I want you to write that down every time. If you do, I guarantee you're going to know how to do these problems on the test. Okay, so let's begin our specific problem. I'm going to leave this this value here. There's a couple ways we could work this problem, and let me make sure that I've got let's see, do I even have that problem in my notes here? If not, we're all going to be working on a problem that I don't even have in my notes. Good. This will give us all a chance to think about it. So I want the derivative of this, so I start with the limit as delta x approaches 0. Again, I was saying there's two ways to approach this. I'm going to give you the general way, and then we're going to take care of this at the point 43. I'll show you how that works. Okay, so here's my fraction line. We got the delta x down there. Nothing's going to change with that. In the numerator, we know what f of x is, don't we? We're given that value. So I'm going to put minus, and I'm going to put parentheses. The reason I'm putting parentheses is if I forget the parentheses, I'm going to forget that I'm subtracting this whole quantity, and you know that's going to affect the sign between the square root of x and 1. So I need to make sure I put parentheses there. Now we go back and we say, well, what do I do with f of x plus delta x? Remember, this is just the input value. And I'm going to put into this function, everywhere I see the input variable, I'm going to put in whatever I have here. So that means I'm going to have the square root of x plus delta x plus 1. So the first step is just knowing what to do. How do you interpret f of x plus delta x? Okay. We want to work this problem down to the point where we can do what? Use direct substitution. Very good. Okay. And right now I can't use direct substitution. It would make my denominator 0. So the next thing we have to realize is, which part of this fraction am I going to work on? The numerator or the denominator? Now, it's kind of obvious for this one because there's nothing else in the denominator except the delta x. But on some problems, it could be a little bit of a question. Which one do I work on? And again, start with the numerator. That's where we want. And what we want to do, remember where we're headed on this, what we want to do is we want to change the looks of this fraction so that I end up with a factor of delta x. If I had this whole thing multiplied by delta x, I could cancel the delta x's if I had a factor of delta x up here. So I'm going to do my best to get this down to where I have a factor of delta x, and then I can cancel with this factor, and the problem is gone. The problem, isn't it, is that we have this down here. Now, this came up on the last quiz, and some of you, I believe it was your quiz, I had to write you a little note on some of yours and ask some questions. So if we're going to do this work here, I've got to multiply this fraction with another fraction. What do I choose? How do I know what to work with on the other fraction? And there's a name for it. We're going to use the conjugate because we want to rationalize the numerator. Okay, rationalize. In other words, we're going to make the numerator a rational value by, we're going to virtually erase or rewrite all of those square roots, and they won't be there anymore. So you said use the conjugate. Now, To use the conjugate means to do what? Okay, and I got lots of signs in here, so we have to be a little more careful. Do I want to switch this one, this one, or this one? Yeah, between the two terms, okay? If you think of these as two binomials, and I use the conjugate of those, I have a plus b, for instance, and a minus b. And so the a is the first radical, and the b is the 1. And then, well, actually, no, I said that wrong. We could have had that, but that's not the problem. The a is everything in the first set of parentheses. Everything over here. B is everything over here. So to use the conjugate, I need to use the square root of x plus delta x plus 1. I'm going to extend that to make sure it covers that. Plus the square root of, whoops, x. Let me make sure I get this all in here like it's supposed to. So let me do some cosmetic stuff. Plus the square root of x plus 1. That's a 1 over there. What's in the denominator of this? Because we're going to multiply it by a factor of 1, yeah, it has to be the same thing. Okay. Some of you on a problem similar to this, I wrote you a little note and I said 2/3. Is that the same thing as 2/3 squared? Now the last one on the last quiz didn't need the conjugate. We just needed to take care of the, well actually it did need the conjugate, and what we ended up doing, people tried to just square that whole thing. This is not correct here, and so we can't just square those. We've got to make sure that we have a quantity here and a quantity here, and then we match those up, but we just change the sign in between. Okay. Let's continue on then with our work. Equals, oh, let's see, if I take this term times this term, let me think about. Man alive, what did I give you guys? Let's see here. Maybe that's why I don't have my notes. Because all of a sudden, I'm looking at this. Do you see what I'm seeing? What are you seeing? I'll tell you if it's what I'm seeing.
Did you put the change of x around in the survey?
No, it's down here. I'm going to stop the timer. And start the recording again. What we need to do, Stephanie, you're the person of the hour here. So if we remove the parentheses here, oh, rats, is that going to work after all? Oh, yeah, because it's plus here, isn't it? If I have a plus 1 and I distribute that, that's a negative 1. You see where she's going on this? Okay, so that ends up with just the square root of x plus delta x minus the square root of x. Okay, what we're doing is if we remove the parentheses from this one, in fact from the whole numerator, who asked me that? Philip? Okay, if you remove the parentheses from this whole thing, this becomes negative the square root minus 1. And then I've got 1 minus 1, okay, which makes it a whole lot easier. You know, we would have gotten our way into that one eventually, but man, I didn't want to go down that road. Okay. One of these rationalizations is plenty for all of us, so I'm going to write this now. If I had more room over there, I wouldn't be writing it out one more time like this, but it bears repeating. Now you said use the conjugate. We're going to do that. And now plus the square root of x. Okay. Okay, limit delta x goes to 0. Now if we look at these are much cleaner binomials up here. Multiply the first terms Connor, what do we get when we multiply the first terms? Delta x, yep. And when I do FOIL, I would normally do, outside, inside, but those are going to cancel. And then we end up doing the last terms, and the last terms is just simply x, okay? Now, take a look at your denominator, though. We're going to have delta x times the quantity x plus delta x plus the square root of x. Okay. As I've watched many students turn in papers on stuff like this. My timer? Thank you. I shouldn't say timer, recording. I didn't stop. They're jealously guarding the amount of lead that comes out of their pencil. If you need more pencil lead, I'll loan you some. But one thing I see is people forget to put parentheses where they need to. It's really important to do that. The other thing is I see people do this. I want you to tell me what's wrong with this. Oops. Make sure I get my hand off of that. Where am I at? Okay, there I am. What's wrong with that line?
Yeah, subtract x out of the top cell. Part of the other.
You can't? I can't subtract x from this x? Really? Well, if I take away those parentheses, I can, right? Okay, so I can do that. It's okay. But that's not what I'm going for. What's wrong with the way this is written? The limit, single value, right? When I find it. The limit, single value, right? When I find it. What's implied between these? What? What's implied? Not equality. You know why? It doesn't say equals. Okay? Implied is multiplication, right? Isn't that what you do when you have this and this, or a quantity, a fraction, 2/3, and then you probably would put a multiplication sign. Implied is multiplication. That's not what you want me to imply from that. So this is what I mean. You need to make sure. If you need more lead, just come up and I'll loan you my pencil. We got to put an equals in there because this quantity has the same value as this one. Okay. Now, again, why did we work on the numerator? What was our purpose for starting this problem like we did? And work on the numerator? Because we had a problem? What was our problem, Ryan? Why did we have to even do anything at all? Why couldn't we just work the problem, leave it like this, Ryan? I'm sorry, what? Nah, I like square roots, don't you? Nothing wrong with square roots. But that's not the reason why we had to work on it. Why did I have to work on this problem? Why did I have to do anything like this over here? Have no idea? What am I doing with the delta x's? Oh, I thought I was approaching 0. Isn't that what that says? You sure? Okay. So if delta x approaches 0, and I can do a direct substitution, what would happen to this fraction? Can we have undefined values? No. So I had to do something to get rid of that delta x. Now, what I did was to use the conjugate. I'm down now to this part. So Ryan, have we helped ourselves at all? How? I can't hear you.
You can eliminate the delta x.
Yeah, because they're factors of their respective values. Okay? So I can do that. Now, Ryan, in fact, I'm going to ask everyone this. Oops, not use of red. Okay. I'm going to see here. The next step would then be, well, the next step would then be this. Right? We forget the ones up there. Good. So it's 1 divided by that. Okay. Now, I'm going to look for an answer from everyone on this. Let you see this work here. Actually, you gotta see it from up here. Whoops, what did I do? I didn't. I said resubmit. Sorry about that. Let's stop that. I don't want you to answer that question. I want you to answer this one. There you go. First one, second one should be gone. I hope. Question is this: what's wrong with the way the last line of the work is written? A couple people know. At least have a response. Okay, again, if you don't know, if you don't see anything wrong with it, you communicate that to me. So I'm going to save this to the portfolio also. So we have a couple of participation marks for today. Okay. Everyone's finding the send button, I see. Three more people. Two more people. Someone's writing me a book. Okay, now we're done. The reason I want to ask you this is because I want to make sure that you don't make this mistake on the test or a quiz or anything. Okay, so let's see what you wrote. Absolutely. Bravo. Okay? Did you see that? Remember what I keep telling you? You have to write that idea. Let's see, we got quite a few. Yes, absolutely. Very good. Oh, you guys are good. I'm glad I took this one. Very good. Okay, great. You've made my day. You don't know how many semesters I've had to teach students that. It's not the same without it. Okay, great. Now, Ryan, I just have to keep talking to you a little bit, okay? So, Ryan, now what? Yeah, because it no longer matters to us, does it? So, correct? No, no, no. I knew I couldn't fool you guys, so I didn't make it in one of those questions. Okay, absolutely not. You cannot write that again because you're doing direct substitution, and our answer is 1 divided by 2, the square root of x. Correct? Yes. Okay. Now, so what? So what? You know, I love that question. Don't you ask that? Who cares? So what? Big deal? Why do we care? You got to go back. What does this represent? Yeah, this is the derivative. But tell me more. The slope of what?
Tangent.
Tangent. Where? On which curve? On which curve? This curve? That doesn't look like slope to me, you guys. Doesn't look like slope to me. So, what are you going to do with this? Let's go back to the beginning. It says, use the limit definition to find the equation of the line. Equation of the tangent. What do you need to know for equation of a tangent line? And point, okay. And if we have the slope and the point, do we have a point? Do we have the slope?
Yes.
Oh, do we really? How quickly you back off on an answer. Okay, we know that we want to evaluate this. The slope of the tangent, and this is going to, this is going to be at what point? 4, 3. So what is the slope at the point 4, 3? What goes inside here? Yeah. This is the input. This is the input of the point where we want to determine the slope of the tangent. So if I do this, I have 1 divided by 2, the square root of 4, or actually 1/4. Now, I need to know, what is it, the equation? What do I need? I need a point. Do I have a point? Check. Do I have the slope? Check. Can I find the equation of this line?
Yeah.
Absolutely. Then what do you know I'm going to ask you to do? Graph it. Graph it. Absolutely. Okay. We've got about 6 minutes before I want to start that. So let's see how fast we can get those graphs done. So take your inspires. You need to know what the original function is. Do I need to go up and show you? There it is. Square root of x plus 1. Okay? Square root of x plus 1. In fact, I'm just going to leave it there. Now, we want to be able to check our